Myself Mudassir Masood, registration number 21T60. So today our lab of DSP is lab number 12, IIR filters, and here is the task number 1. Given the DSP system with initial conditions y of minus 2, y of minus 1, x of minus 1, and the input x of n, and we have to compute the system response y of n for 20 samples using MATLAB. Following code will be used, and here in the MATLAB I write the code, and the output for this task is here. Input signal x of n, and the output signal is y of n here. So next we have task number 2. Given a transfer function depicting a DSP system, h of z is equal to z plus 1 divided by z minus 0.5. We have to determine in part A the impulse response h of n and the step response y of n and the system response y of n if the input is given as x of n equal to 0.25 raised to the power n u of n. Here is the MATLAB code for this task, and the output of this task is here. Impulse response h of n and the step response y of n and the system response y of n for x of n 0.25 raised to the power n u of n. So next we have task number 3 for this lab. Given the digital transfer function h of z, and we have to plot poles and zeros using this function to find and plot frequency response in the MATLAB. So the MATLAB code for this task is here, and the output is this. This is the plot of pole 0, and these are the poles and these two are zeros. Next task is task number 4. The following transfer function describe digital systems, and we have to sketch the z-plane pole 0 plot and determine the stability status for the digital system. So the MATLAB code for this task is here, and the output of this task is pole 0 plot for the h of z. So the next task for this lab is task number 5. Given a digital system y of n equals x of n minus 0.5 y of n minus 1 with a sampling rate of 8000 Hz, we have to determine the frequency response. Here is the MATLAB code for this task, and the output of this task is here, magnitude frequency response plot. Next we have task number 6, that is consider the following digital transfer functions, and we have to plot the poles and zeros on the z-plane, and use the MATLAB function to plot the magnitude, frequency response, and phase response for each transfer function, and identify the corresponding filter type. For example, low pass, high pass, band pass, or band stop. Here is the code that will be used in this task, and in the MATLAB I will code this task here, and the output of this task is here, plot of pole 0. So the next task of this lab is task number 7. For the following feedback filters, determine the locations of the poles and zeros and plot the positions in z-plane and compare these two results. So here is the MATLAB code for the filter 1 pole 0 plot, and for filter 2 pole 0 plot, and the output of this task is pole 0 plot for filter 2 and the pole 0 plot for filter 1.